Assalamu alaikum. This is Ihtishamul Haq from Electrical Engineering Department, Sakkar IBE University. Today in this video, I will present my final year project with title Performance of Grid Connected PV System by using DSTATCOM. My supervisor is Dr. Mudassir Munir and co-supervisor Engineer Ghulam Akbar. This will be my presentation flow. Introduction, aims and objective, motivation, literature review, methodology, MATLAB modeling and results, conclusion, future work, references, poster. Introduction. As we know, the world is rapidly diverting toward renewable energy, especially solar energy because of environment friendly and cheap cost. Due to the national subsidy policy and the demand of energy, photovoltaic power generation is growing at a rapid rate all over the world. When new PV installation connect to utility grids, some problems such as harmonics, voltage stability, and power quality is the most concern. Here, in this project, I use DSTATCOM distribution synchronous static capacitor as a voltage source converter and as well as a reactive power capacitor for power quality improvement in grid connected PV system. Aims and objective. Main aims and objective of this project is MATLAB simulation of grid connected PV system with DSTATCOM, checking performance of different grid connected PV system topologies by considering economical point of view. QQ improvement or yani power quality improvement in grid connected PV system. Motivation to contribute in green energy technologies to solve the disturbance issues in PV penetration in grid. Literature review. This is some research paper that I have through in. These are related about DSTATCOM and grid connected PV system. So, methodology. Here is the proposed grid connected PV system by using voltage source converter as a DSTATCOM. Here I use a PV array of 100 kilowatt boost converter to boost the voltage of PV. Voltage source converter with a STATCOM based controller. This is a smart technique. LCL filter for harmonic detection. And this is a grid supply toward load. And this is a point of common coupling of PV power and grid power toward load. So this project is about grid-connected PV system with DSTATCOM by using MATLAB simulating for modeling MPPT-based PV system and uses of DSTATCOM as the grid-connected converter to realize power coordination, voltage stabilizing, and power quality improvement. The basic control strategy is closed-loop control strategy. By decoupling active power and reactive power, inner loop control algorithm is used to trace active power and reactive power current separately. Meanwhile, outer loop regulates DC link voltage and grid connected voltage. So, STATCOM is for distribution is called distribution static synchronous capacitor as a DSTATCOM is a shunt device belong from FACTS family, flexible acid transmission system devices. It is used for electronics control power flow and improve transient stability and contribution distribution network DSTATCOM. Regulates reactive power or voltage at its terminal by controlling the amount of reactive power injected into or absorbed from power system. Basically, this should come connect to the system as a shunt device. For example, this is without DSTATCOM power flow toward load from grid. As we can see that there is a power and active power and reactive power both are flowing toward load. So when we connect DSTATCOM in parallel to the grid supply to our load. So the reactive power is supplied by this DSTATCOM and the only active power from the grid line. So we can see there it will help in minimize the losses in the grid lines. So main components of DSTATCOM, basically it's required DC source, voltage source converter, PWM based control system for switching of voltage source converter, and filter for the harmonics detection. PV system. Here I already mentioned that I used a 100 kilowatt system in which 47 was a parallel string and series connected module per string is 10. For MPPT, I use perturb and absorb algorithm. So here we can see this is a PV array, DC-DC converter, means boost converter, MPPT based control system to track maximum power and this load. And this is the perturb and absorb flow chart, which basically use comparison to track the maximum power. So this is a design segment of DSTATCOM standing on DSTATCOM. Actually, I used SRF synchronous reference frame theory, also called DQ theory for our control system. As I mentioned already in introduction, for active and reactive power, I used DQ theory. So here we can see this is a DC source, voltage source converter, LCL filter, and this is a load, and this is a grid supply. This is a full DSTATCOM control and PWM generator to switch the voltage source converter, and this is a measurement window. So basically here we can see that load is required 200 kilowatt active power and 100 kVAr reactive power. So here we can see that the reactive power is supplied by DSTATCOM and the active power is supplied by grid. And the reactive power from the grid is about to zero. So this is basically the DSTATCOM work. This is some current and voltage result of DSTATCOM, which is quite stable and look good. So here is a MPPT based boost converter with PV system. I use standard irradiation and temperature, 1000 watt per meter square and 25 degrees centigrade. So here I use a 100 kilowatt PV array with the MPPT controller base of perturb and absorb function and boost converter for boosting voltage of PV. So this is a window for measurement. This is some results, and we can see that when a radiation is maximum and temperature, we can get a maximum power of 100 kilowatt. This is some characteristic with current voltage and voltage power. So here is a generative power is almost 100 kilowatt, which means this is a good system. PV voltage is about near to 400 and PV current is near to 250 ampere. So when we boosted the voltage of PV, so it's almost 800. So here is the proposed mass simulating model, which I use same standard radiation PV array MPPT based boost converter, inverter, with smart control system, STATCOM based, LCL filter for harmonic detection, and this is a grid supply to our load. This is a PCC, point of common coupling. This is a power flow measurement, and this is a voltage current measurement window. As we can see, this is a smart control system for voltage source converter, PWM generator control to switch the inverter switches. This is phase lock loop to detect phase of the reference voltage and currents. This is a inner loop for active and reactive power control basically. So here is a flow of power from PV and grid side to our load. We can see here that the load requirement is 200 kilowatt active and about 50 kVAr reactive power. As we can see that our system, PV system, is a 100 kilowatt system. So 100 kilowatt is provided by PV and 100 kilowatt by grid side. But the reactive power is from the PV side because I use a DSTATCOM based voltage source converter. So this is a main quality of this project, that we can use PV this smart system not only provide power from PV to the grid and as well as compensation quality. This is a load with this STATCOM variable condition. As we can see, when the radiation changes in day and angle, so the active power changes, but reactive power is the same as the requirement. There is without this STATCOM PV and PV grid connected PV system power flow. As we can see, the PV provide 100 kilowatt to the load of 200 kilowatt and 100 kVR load. As well, grid also provide the rest of power and also provide reactive power, but the PV system only provide active power, which is very big issues in transmission line to adjust such a reactive power, which is causes very losses. So this is a current and voltages. This is a grid voltage and current is a reference, and this is water voltages and current. After using LCL filter, the results of voltage is quite very good. So this is a load. We can see there's a stable uh, flow toward. So this is FFT analysis for harmonic detection. We can see when before using LCL filter and after LCL filter, the harmonic is very low, which is quite very, very quality system. So conclusion and future work recommendation. As we know, the grid connectivity generation is a future trend. This mental lab simulating based project will help us that how can we make grid connected PV system better by using DSTATCOM to mitigate power quality issues, called PQ issue, and contribute to the development of renewable energy power generation and smart grid. For future work recommendation, I show some future recommendation, which is improvement with battery bank for night time. So we can use this system for night as a STATCOM. Also, single STATCOM can be used. This is some paper references, as we can see. Uh, so please subscribe and to our channel for more project video. Thank you so much.